Hello and welcome to the third video in the series on programming with Python and R. In this video we'll cover using functions and methods. So if you've already been exposed to these languages a little bit, you've probably picked up on some of this, but I'd like to be explicit to make sure we're all on the same page with what a function is, what a method is, and how you use them. The learning objectives for this video are understanding the difference between a function and a method, understanding how methods are used differently between Python and R, being able to pass arguments to functions and methods both using a positional and a named approach, and being able to find documentation explaining how to use a function if you need some help. So as a reminder, there's a table of contents in this video, like there is in every video if you want to skip around. And if you haven't watched the previous videos, you can look in the description for links to the dataset and previous code so that you can jump right in here. So let's start a new Python script for today. And what I'm going to do is I'm going to grab these first two lines from our last script so I can just get the data that I imported previously in the data import script. And I'll save this and let's call it using functions.py. So as we learned in the previous video, we can get a subset of one of these lists by slicing. So I'm going to grab 20 of these items and I'm going to start 11 items in just because the first of these are all kind of the same thing. And I'll make a new variable name for that new list. And I will print it out so that I can see what I've got there. All right, so here's a variety of different stem heights, 20 of them from near the beginning of the data set. So there's a function I can run on that called sorted. And let's print out what the results of that are. Right, so here's the first list that got printed out, and now if I send that list to something called sorted, I get those sorted in order from smallest to largest. But if I look at the original again, I see that I didn't change the original, I just printed out something new and it didn't modify this sh sub. So if I wanted to actually save that as a modified object, I might do something like this. Okay, so I have the original, I have the sorted one, and then if I look at the original again, it's unmodified. So this is generally how functions work, kind of how they're defined in programming languages in general, is that they have an input, they do a particular task, and they have an output. And a function will always behave the same way, or at least that's supposed to be how it works, if you give it the same input and output, unless it's something that's supposed to generate random numbers or something like that. But generally we think of functions as trustworthy, like if I run this function on this particular object formatted this way, I'm always going to get this particular output. Now let's go find some documentation so that we can learn more about this sorted function. So if you go to docs.python.org, you're going to find all of the official documentation for Python. Not all of it is really meant for beginners, but they still at least have a tutorial that you can look through. So that would be a great way to supplement this tutorial video series, in fact. But anyway, I'm going to search for sorted, see what I find. All right, so near the beginning, I get a documentation for the function. This how-to might also be handy sometime later. But let's go look at this. Right, so this is sort of a list of built-in functions, and it's taking us right to the one for sorted. So what we see here are these things called arguments. And arguments are your input to a function. Right, so when we gave it our list, that went into this argument called iterable. And then this, well, I guess they don't in this documentation actually, no, they do refer to it by name. So whenever you see this name iterable down here in what's described, it's talking about that list that you gave it. Returns a new sorted list from the items in iterable. So that makes sense. That's exactly what we saw. It made a new list and it didn't change the original one. And so we have a couple other arguments here. So we have key equals none. So key would be, you know, if we had something else that we wanted to do to it, that we wanted to change how it was sorted. And we have reverse equals false. And you'll know that some of these have equals and some of them don't. So part of what the equal sign is indicating is that this has a default value. So if you don't specify key or reverse, this is what it's going to default to. The other thing about this is that these are named arguments. So for this iterable one, whatever we put first into sorted, it assumes it's going into that. For these others, we actually have to type the name of the argument and then an equal sign and then what we want to go into that. So for example, if I go back to Thani, if I wanted to sort this list in reverse order instead, I would do it like that. And remember in Python, when we do true and false, we capitalize the first letter, not the rest of them. And so now if I rerun that, I see that the list got sorted in the opposite order. Now I'm going to introduce something similar to functions called methods. A method is like a function, but it's specific to a particular class of object. Like a list is a class, it's a type of object you can have in Python. And it has a method called sort. So if I wanted to do that, I would actually first type the name of my list, and then a period, and then I type the name of the method that I want to use. So I type sort, and I'm going to put 2 parentheses after that because it does have that parentheses notation like a function, but in this case I don't need to give it any other arguments. And after I've done that, I'm going to print it out again to see what it looks like. So we'll see in this case with this last one that I printed out, we'll see right before I did the sort method, it was not sorted, and now it is. So in this case, I have changed the actual list itself. So these two do very similar things, but the function returns something new without modifying the original, versus a method is capable of modifying the original. Okay, I'm going to show you a couple other methods as examples. First, I'm just going to do something quick where I convert sh subbed from an array to a list so that I have access to all of Python's list methods as opposed to NumPy's array methods. So I'll just use the list function. Say I want to take this array and I want to make a list out of it, and then I'm going to basically overwrite that variable name right here. So if right now I can see that this was an array in the final output, and if I run it again, now it's a normal list, which is more something for like Python base installation as opposed to NumPy. Okay, so another common method that you might use with a list is called index. And so what index does is it looks for the first time it finds a particular value, and then it tells you what is the index where it found that value for the first time. All right, so I'm just going to add a print command there so that I have the list exactly as it is printed out right before I do this index. And let's say I want to find the first place that I find the number 1.53. And I'm going to put that into a new object. I'll call it my index. So after that's done, let's print out my index. And we'll print out the list again to see if it changed. Right, so in this case, it first found 1.53 at position 6. So if we go 0, 1, 2, 3, 4, 5, 6, that makes sense. That's where we were expecting it. And then if I look, this method didn't do anything to change the original list. So a method can return something a lot like a function can. Another example is something called pop. Right, so let's assign that to a variable, and we'll see what that does. So if we look at the output of pop, so what it returned was a value, and that value was the last item in the list. But then if I look at the list after I ran pop, now that last item is gone. So pop is a method for if you want to work with a list and one at a time you want to take something out of the list and do something with it, and then you just want that value to be gone once you've processed it. Right, so this is sort of a way of chewing through a list and doing something with it and then getting rid of it. So anyway, this is an example of a method that both returns a value and modifies the original object that called it. Okay, so as an exercise for the Python portion of this video, I want you to look into string methods. So you can grab a string, you can either create something like this, or you can grab one of the strings from the species or accession list. Say if I grab the first accession, right, so then that's just a text string and not a list of strings. So I'm going to put up a link to finding the list of methods for strings. And so I want you to try some of them out and see how they work. And so for one particular one, lower, see what it does and figure out whether it returns a value or modifies the original string. All right, welcome back. So if we take a look at this, so here we have it printed before and after running that method, right? And I can see that it looks exactly the same. But say I make a new one using that method to see if it returns something, and then I print out the new one that gets returned by the method, that one got changed. And this is maybe not what you expected, because why wouldn't you want to modify the original like this? I mean, you can modify lists like this. But in Python, a string is something called an immutable object, which means it's not allowed to be changed, versus a list is mutable and a list can be changed. Like, you can always overwrite the variable. Like I could change it this way, right? But I can't change it any other way. This is basically creating something new and then putting something new in that variable name, and then the original variable's gone. But I can't just change it by a method by itself. Okay, so let's get started with R. I am going to make a new script, and to import the data that I imported during the data import tutorial, this time I'll be lazy and just do source to run that whole script, especially since I renamed some of the columns there. Of course, it prints out a bunch of stuff because I had that script print out some things. And it makes a few other objects here that I don't care about, so I can use the remove function to clean up and get rid of those. And then I've just got my data set. So let's get that same subset of data that we got in the Python tutorial, where I got stem height values for the 11th through 30th observation. Oop, not 300, okay. Right, and so there is a function called sort in R, so we're going to do this in sort of in parallel to what we did in Python. And here I'm not using that period. In fact, that syntax is not going to get used at all in R. You're always going to put an object in as an argument. And so if I run that, I see the sorted version of that vector. And if I look at the vector again, it is not sorted. So this is acting like a function. So we have an input and we get an output, but nothing else has changed. So if I wanted to keep the sorted version of it and maybe keep it in a different variable name, I would do it like this, right? And then if I just want to see what the new one looks like, I have that. Right, so if I look down here, I can see, okay, here's the sorted one and here's the original one. So let's take a look at the help page for sort. So down in the lower left here, I'm typing a question mark and then the name of the function. And then down in the lower right, that brings up the help. All right, and so I see my usage. I have X, which is, so the sh sub object would have been passed to the X argument. And then I see I have some, or at least one here, named argument that I could use. Right, so a lot like in Python, I can put in a comma and then set that argument to be something else like that so I can name it. Right, and so that is the equivalent of the reverse argument in Python, where it's sorting it in the opposite order. Another thing about R is that really it's okay to name any of your arguments, and sometimes that can be helpful. Like, I mean, okay, so naming X is probably not that helpful, but in general, it can really help with looking at your code later and understanding what was going on. On the other hand, it's also okay to not name your arguments at all. So I could do this, where I delete this part. And if I run that, it still works right because it's assuming that they go in the same order that you see them here in the help page. So if I try doing that in the opposite order, then it's not going to work. right? So then it's saying decreasing must be a length 1 logical vector because it thinks that this sh sub is what I was passing to decreasing. So that doesn't work. However, it uses names before it uses orders, so I could potentially name both of these. And then it works again. So there are a lot of different options for how you pass arguments to a function, and really readability is the highest priority. Like, I would prefer this one because I don't really need to know that this is x because that doesn't really say anything. But knowing what this true was doing is going to help me understand what my code was doing. Now you'll notice on the help page it actually also mentions methods. And it mentions that we have this default method, right? And so that gives us an additional argument. So technically, when we were using the sort function, the sort function then calls this default method to run on the objects that we pass to it. So methods are used quite a bit differently in R than they are in Python. In Python, a method is like something that really belongs to a class, versus in R, a method is sort of like a subversion of a function that's designed to work on a particular class. So most of the time you don't even really have to think about methods because you're going to use them exactly the same way you would use functions. And in R, this is really important. No value ever changes in your environment unless you use that assignment operator. Right, so you're never going to change the value of something that you've stored in one of your variable names unless you've got this little arrow, or an equal sign if you prefer the equal sign. Okay, so for an exercise for the R portion of the video, I would like you to take a look at the help page for the summary function. And take a look at that because that does talk about different methods. So I want you to try using summary on the myData data frame as well as the sh sub vector and see how the results are different based on whether you give it a data frame or a vector. And lastly, to practice using arguments, I'd like you to try using summary putting the digits argument before the object argument. So pause for a few minutes and try that out. All right, welcome back. So I'm going to type in question mark summary to get the summary help page. Now actually just by typing that in, I see a whole really big list of summary methods here. So in R, a method name is sort of the generic function name and then a period and then the class that it's supposed to go for. But generally you don't actually type out this period in class, you only type out the function name and then it selects the correct method based on what class you give it. So I'm just going to look at the main page for summary. Right? So summary is a generic function. That just means a function with some methods, and it's used to produce result summaries of the results of various model fitting functions. And here we're not going to actually run it on model fitting results. We'll just run it on a vector and a data frame to see what it gets. So we have this class specific for data frame, and we can see what that looks like. Remember that my data is a data frame. I could even check that. Right, that's a data frame. All right, and so if I do the summary on that, here I'll minimize this so we can get a better look. I get this sort of summary of each of the columns. So it's going to tell me, you know, what was the minimum and maximum, mean, median, first quartile, third quartile. And for things that were text, it's just going to tell me basically how many observations that I had. Versus if I run summary on a vector, so as a reminder, sh sub is something called a vector. I get a similar printout with the median and mean and other information, but then it's just for that vector. So this is behaving a little bit differently depending on what it's getting. And so, yes, probably for a vector, I'm just getting the default method. We see we have ones for things like factor or a matrix, and you saw, as we mentioned earlier, there are ones for if you fitted linear models. All right, so part 2 of this is I was asking you, how would I put the digits argument first? And if you recall from what we just talked about, that you could do that by naming all of your arguments. So let's say, so here, we'll do it for SH sub. I got 3 digits. Let's say I wanted 5. So I'm going to say object equals sh sub, and because I've named it, now I can do any order that I want. So that actually, I think it rounds it because these were only measured to 3 digits. Let's say digits equals 1, right? And then, right, it's just giving me it as an integer. Or I could say digits equals 2, and then it's just giving me the first decimal place. Right, and so this is the way that I can put these arguments in a different order, is by naming them. And I could probably do that also with the data frame. Right, and now it's limited in terms of how many digits it prints out. Okay, thanks for watching, and in the next video I'm going to show you how to make your own functions, which can help a lot with avoiding having to copy and paste your code.